going. Welcome to the stream. Welcome to the stream. Alright. Thank you everybody for joining the stream today. A few things I want to cover. Sorry about not being available last week. I was sick, starting a new diet thing. I was taking some time to adjust to that, but we're back and we're ready to go, and we're going to learn some C, and we're going to do some cool things, and I appreciate you joining me along with this journey. So without further ado, let us jump into the main screen and see what we have going on. So what we left off with last week was section 17, where we were looking at the multi-file projects. I want to do something a little bit different today. I want to do a practice problem because I did, as I said, I was away for about a week, and I really didn't do any programming either, so I wasn't feeling really well. So let's do a practice problem. I'm going to show you kind of a cool way to use ChatGPT to help you do a practice problem. I did mention that we weren't going to use a lot of AI to produce our code, but we can use AI to help like tutor us along and things like that. So I think it's a really cool kind of way of using it to given. Well, let me just jump into it and I'll show you what I mean. So let's start with first taking a look at the channel. Can you guys believe we're at 100 subscribers now? That's all you. I thank you guys, everyone who's joined, who's subscribed, everyone who's told people about it. I really, really do appreciate that. So what does that mean? Well, we know what that means. That means that we need to do a stream where we're going to do a full-time stream, maybe a couple hours. I have to do it in the next couple of days, I'm going to be out of town. And we're going to do something from end to end, build a cool little celebration for 100 subscribers. I do plan on putting out a short form normal YouTube video just thanking everybody, and we're looking forward to the next 100, so continue to tell people. I have like a cool idea. What I would like to do is like Fibonacci, so we reached 100 this time. The next cool thing would be reaching like 300, then 500, 800, and so on, Fibonacci sequence, all the way up to where it starts to not make sense, right? Where the multiples of the Fibonacci kind of grows. That function can grow pretty quickly. So that means that we would want to switch over to something else. But again, super excited that we hit 100. I know we were pushing for it. I wasn't sure if we were going to get there as quick as we did, but it's really awesome, and thank you guys for joining me along the way. So let us go ahead and look at the ideal that I was telling you about, where you use a ChatGPT to help you. So as you know, I think I mentioned a few times that I was using the Learn C the Hard Way along with this. So Learn C the Hard Way by, can't remember his name, I will tell you in a minute. Z.A. Shaw. So I really liked Learn C. I did actually buy the the course where he has like videos and he kind of shows you how to do stuff. But in general, what he has said, and he lets you know, is all of the source code for Learn C the Hard Way is actually on GitHub, right? It's freely available on GitHub. All of the lectures, all of the source code for them. So specific to lecture 17, we wanted to, it was working on using structs and pointers to structs along with malloc memory allocation to do an exercise. So if we quickly just like kind of open the code, oh actually I'm sorry, it's exercise 16. I apologize, 17 is a little bit too high. So exercise 16, we can look at the code and you can see what the solution is. But what I want to do is, I went to ChatGPT earlier today in preparation, and I said, because I do know the source code and I've done it, but I wasn't looking specifically at source code. But this is kind of my prop. I said, given some source code I'll provide, please create a specifications document or exercise for me to code the solution. Do not spoil with any source code and do not solve the given problem. So essentially, I'll give you some source code and you give me an exercise that would be expected to be the result of producing a similar solution or cover the requirements that the source code provides. Does that make sense? Of course, the AI spit out a lot more stuff than necessary to say it made sense. But what we're left with in the end is, okay, I said below is the solution to exercise 16 of Learn C the Hard Way, so you have some background information. I simply just pasted in the source code and see ChatGPT outputs the information. So perfect, this is a great exercise to reverse engineer into a spec. I'll structure this like a Learn C style assignment plus spec with increasing clarity but no implementation hints. So what I want to do is I want to take this specification that they gave us and I would like to, well, first I want to ask for it in, you know what, I'll just copy it over. Let's just copy it. And we'll do, we're going to do Emacs full screen today. So we can split the screen and put that in there as a, oh, I want that screen to be closed, so kill that buffer. Yeah, but I actually don't want, how do I remove window? Is it like 4? No. Kill buffer and window 0. Yeah. Okay. So then I got the split screen. So what I want to do is go over here and I just want to, I guess we could do it in the Scratch if we wanted to. We'll go back to Scratch. Oh, I don't have a Scratch anymore. Wow, that's crazy. So let's just do, we'll do a, let's go to our source and we're doing C, we're learning, let's do, let's learn C the hard way, and we'll say that this is exercise 16, and we'll say this is main.c because this is the exercise code that we want. So there we go. So we have that there. I do want to move them. I wanted to put it on the other side. So let me do that. I'll just go here for that, and then we'll split it again, and then we'll go over, and then I want to also do a exercise.org file in here, and we'll paste in all that information. So, and then let's make it a little bit bigger. Okay, so that's pretty big, so we can see it. So let's go back up to the top, and let's continue. We'll work through this specification document as if it's an exercise. I know that ChatGPT did spit out a lot of extra information, but we'll kind of work with it as it is, and let's work through it a little bit, see if we can get majority of these features created in there and have a good idea. So the first thing we want to do is we know we're going to use standard input. We know we're going to use, we're going to be needing to use our standard input IO, right? So we'll just set ourselves up with a scaffold for a main function. Of course, we'll print the hello world, right? And we'll save that, and then we can directory, yes. Okay, so we'll save that, and then we'll also create a makefile. This makefile is going to have our normal C flags, which are the all errors, extra errors and warnings, standard equals C89. We want to be pedantic with that, and we want to output debug symbols. So main does depend on main.c. That's going to be pretty much our only dependencies. So we're going to say GCC, and we'll call in our C flags there, and then we'll say output main to main.c. that should give us a way to compile our file. Now we'll go back to compile, and we'll delete all that, and we'll say make. And then we got our compilation done. Okay, so if we go back to the terminal now, we should be able to go back home to our source, C, learning, learn, see the hard way, exercise 16, and then we should have our main file in there, and it says hello world. So we're at a good place to know where we need to be. We're at a good place to continue on now. So let's go back here and switch this buffer back to the exercise. We'll go back there and we'll just use it left to left. So it says design and implement a small C program that models a person using a dynamically allocated heap allocation string. Oh, that's not. What? Design a dynamically allocated what? Oh, let's do word wrap, I guess. Toggle word wrap. Why didn't it word wrap then? Word wrap? Word wrap? How come it's not word wrapping? Oh, because okay, so let's see. How many? Let's wrap at like 60 or 80. We'll wrap at 80 for this. Okay, so set width, or toggle fixed width. What does that mean? No, I didn't want that. One second, I'm trying to figure this out, how to word wrap. I thought it was column width. Column width. Width column. I thought there's just set column, set width. I don't know why it's not word wrapping. Org set. Let's look in here. Let's go to like here. Org mode set wrap org column width. Yeah. No, I don't want that. No, I don't want that. I want the org. You can set the column width by using visual fill column mode. Visual fill column mode. That's not a thing. AI, you're wrong. Org set wrap. Truncate lines. Oh, it's truncate lines? Okay. Let's go and try that. Truncate lines, set Q. So the let's just do it in here. So we'll do a source. Source Emacs, or just to elist, right? Set Q, truncate lines 1. Okay, so did that do it? Let me kill the buffer. And oops, open it back up. Oh, why is the org not there? Yeah. It didn't truncate the lines. Yeah, it's not truncating the lines, so I don't know what this truncate lines recommendation is. Let's go back and look at it. Org startup truncate. Truncate lines equals wrap. Oh, nil. Oh, I want to set it to nil or 0. So did that? I mean, maybe nil, I guess. Ah, there we go. Yeah, so it's truncate lines nil. Okay, cool. All right, with that out of the way, let's go back here. Heap allocation, string duplication. Create a structure that represents a person with the following attributes. A name. Okay, so let's create a struct then. So struct. Struct that represents a person. Person. And it has a name is a string, so we're going to do char star name. Age is an integer, int age. Height is an integer. Height is an integer. Oops. Int height, int weight. Okay. You must implement functions that manage the life cycle of a person. Creation functions. Accepts all attributes as parameters. Allocates memory for the structure on the heap. Stores a copy of the provided name, not just the pointer. Initialize all fields. Returns a pointer to the created structure. Okay, so it's returning a pointer. So that is person star person. No, wait, create person create, and it accepts in all attributes as parameters. So it accepts in char name, int age, int height, int weight. What is this? Struct person, yes. Okay. And so we need to allocate, accepts all, allocates memory for the structure on the heap. Okay, so I need memory for do I need memory for the, okay, so let's do, I have a question. Do I need memory for the name. So let's do the others first. So I know that we want a size of person struct. So we need memory for that, or the pointer for that. So is that just using mem? Yeah, see, it's been 5 days, so I have to review my understanding of it. Okay, so my understanding is that we need the size of, so I could say size t of person. Oh, size t I don't have, right? Except allocates memory for the structure on the heap, stores a copy of the provided name. Do I give that? So let's look at the documentation for a minute, because Malik. It's a void pointer, or it's a void. Allocates size bytes and returns a pointer to the allocated memory, not initialized. Okay, so I can call it person. The memory is not initialized. If size is 0, then Malik returns a unique pointer. So, int is 32 bits and the pointer is 64 bits because I'm on a 64 machine. So, it would be long person equals Malik size of struct person. Declaration. Long pointer, yeah. Pointer person. Yeah, standard lib. We do need standard lib. Include standard lib.h. Okay. Unused variable person. Okay, so there is. And then if I just want to print out, let me just test. The size of person is LU, I think? Or is it ZU? Don't remember. I think it's LU because it's C99. And return person, I guess. Let's call that function person create with Keenan Lynch. Age is 44. Just turned 44. Height is 72 and weight is 237 actually. Okay, so let's compile this. Unused parameter weight. Warning format. Okay, so let's see what we get here. Size of person is, oh, because that's not the size. That's the pointer of the person. That would be the pointer, not the size. Yeah, so we have a pointer. So that's our pointer to person. But we want to struct. Oh, we actually do want struct person pointer. Yes. Okay. Yeah, yeah. Okay, and then we want to say person dot age equals age. Person dot height equals height. Person dot weight equals weight. Okay, and then the only thing we didn't do is aggregate the amount we needed in the heap for the name. So, how do we do that? Let me think, because I'm unsure. Let's see. Let's go back to OBS. Okay. So this has allocated us the, but now we need the size of the name, a pointer for name on the heap as well. Okay, okay. So let's say it is a char star pointer name. What would I name it though? Let me say it's name a memory. I don't know. Name P for pointer. Malik. I guess I could just give it. Is there a string? Let's see, is there a string apropos string copy? String dupe. Man string dupe. X open source is greater than or equal to 500, or okay, X open source is greater than 500. Okay, so we need that all the way at the top here. Define X open source equals 500. Okay. Let's compile again just to make sure that didn't do anything for us. Too few arguments to Malik. Yeah, that makes sense because that didn't Yeah, that does make sense to me. GA, and then we'll just copy it out for a minute. Recompile. Unused parameter. Yeah. Okay, so let us go back to here and work back on that now. So we don't want to use that. We want to use the string dupe. So what's the documentation for that again? Let me move this over here so you guys, so it's not messing up the chat window. And I probably should move the chat window down today. So let's move the chat window here. Or I guess I could move it down a little bit further. I don't want it to take up the mini buffer and stuff when that happens. I guess I could move it over here. Yeah, let's leave it there. Okay. So back to the documentation for string dupe. Description: string dupe function returns a pointer to a new string, which is a duplicate of the string S. Memory for the new string is obtained with malloc and can be freed with free. Okay. So constant char duplicate of string S, duplicate of string S, size T, duplicate of string S. Okay, so you just literally call string dupe. Okay. So let's then, because we know we have a char pointer, so that's a 64-bit, I mean, it's a pointer to a char, so we can simply go person dot name equals string dupe and name. We don't find that though? What needs to be included? Oh, string.h. Yeah. Include string.h. Okay. So that we have, that's spelled wrong, person, spelled wrong again, okay. So if we have that, then we can recompile. Boarding implicit function, did you mean string dupe? String, no, I thought assignment to a char from int makes pointer from integer without a cast. Oh, yeah. Char star. Okay. Recompile. Different size. Cast a pointer from integer of different size. What does it need to be then? What does it need to be? Implicit declaration, string dupe. Why? I have the define open source. Isn't it's not the right one? I'm not using the right one. X. Oh, it's one. Oh my god. There we go. And it's like that, right? Yes. Why isn't it? Do I just do 500? No, that's not right either. Okay, let me look at feature test macros. Man, feature test macros. Because I can include, define, yeah. So I just need to define it. I just need to define it. Okay, so no, it still didn't find it though. Yeah. This is equals 500. Why? What am I doing wrong? I thought I got this working before. La 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 la. In order to be effective, a feature must be defined. Da da da. We're reading all this. Reading. For any value less than. Oh. Oh, so I should do something else, I think. Okay. Let me do. Oh, it's created. Or. POSIX C source. POSIX C source. Let's do POSIX C source. POSIX C source. Compile. Greater than or equal to what? 200,809L. L. Has no right hand operator. What am I? Features. Operator has no right hand operand defined. Has no right hand operand. Has no right hand operand. Wait, I don't remember what it was. 200809. L. Oops. Recompile. There we go. Now we compiled. Man, that was annoying. Okay. So let's go back to our. Oops. And then let's continue now. That was annoying. That was a bit annoying. It was annoying. Were you annoyed? I was annoyed. We were all very much annoyed. Yeah, you can't see anything, so I'm gonna go back over there. I don't understand. I think it's just this background. The prelude is kind of cool, but I was thinking about starting with my own, going back to having my own, what's the word I'm looking for? My own init file, and then kind of working, customizing it from there. So, okay. So we have done that. Let's also now assert that, and we have to insert. So person is not equal to null, right? Because that would be bad if that was the case. And we're gonna have to include assert in there. Assert.h. Okay. Recompile. Good. All right. So. I don't like that every time it compiles, it's doing it in, where am I at? I don't, That's doing that. Oh, I can just go there and hit quit. Okay. Okay, so we've asserted. We've verified that for here we could just use the string dupe. So we've created a person. Return a pointer to created function. Destruction function. Accept a pointer to a person. Freeze all memory associated with the person. Must safely handle invalid input assumptions. Use assertions or checks. So a destruction function. So let's say we do void person destroy struct person assert person is not equal to null again. Okay. And we need to assert that person dot name is not equal to null. Oh. Person name. And then we need to free person name and free person. Okay, so that destroys it, I think. Okay, now display function accepts a pointer to a person, prints all attributes in a readable format. Output should clearly label each field. Okay. Prints all attributes. Okay, void person print struct person. Printf name percent s person name printf age age percent d and person age. Okay, let me see if this is working as it is right now. I'm not creating no compile. Okay, and then let's do, so we did create Keenan, so we'll do Keenan struct person pointer Keenan equals that. Okay, and then let's do person print Keenan. Okay, so compile that. Struct person. Oh, yeah. So we don't need the hello world now. Recompile. And then let's go here. Let's hope we don't get no seg faults. First try. First try. First try. I didn't do the replay buffer, so I don't know. I didn't have the replay buffer, so I'm not sure if that's going to go well or not. But I say it's a good first day back because I am just looking at documentation and able to do some memory allocation and deallocation. I mean, this was super simple for the guys back. So here's the thing. Here is the thing. Here is the thing for you guys. This used to be part of normal day-to-day programming, right? Understanding, keeping track, and wanting to know what's going on with your memory and how much memory you're using. And we've kind of gone away from that which is good because it's allowed us to create really faster things and kind of accelerate. But along with that, we as programmers got lazy. We started to not worry about how the underlying code was working, or me and myself at least. I spent almost 15 years as a full stack web developer. So you never had to really worry about memory except if you were opening way too many instances of a pool back in like old ASP days, and you were overusing resources, but you weren't worrying about memory at the byte level like you're doing when you're doing this code. So that's the crux of really why I'm doing this, so I can understand that, and it's a joy. It's a joy to understand, to see that, like, here we said, give us the memory from the computer's pages, from the memory. Give us just enough memory to give us a person, right? And we can presume, we could like go here and say, okay, so this should be, this is a char, this is a pointer. It's a char pointer. So what it's going to give us is a memory location that points towards an 8-bit space, right? So this is 1 byte, right? This one is 4 bytes on my machine. It should be. This one is 4 bytes on my machine. And this one is 4 bytes on my machine. Now it's going to holler at me because it doesn't allow that in C comments. The styles aren't allowed there. So I would have to change these to be, I should have just did that, right? I don't know why I didn't do that. Let me, and I could probably just go like that. No, because it does the whole, what could I do? I could go here and go forward though, and maybe if I do like that, no, that didn't work either. So I'm just gonna go here and just do 1 byte like that, and we're gonna just do like that, and we'll just. This is not good Emacs keystrokes right now. I'm failing. I'm failing the Emacs gods at the moment, and I apologize to them about that a lot. And then that's 4 bytes as well. 4 bytes as well. And then this one is 4 bytes as well, right? 4 bytes as well. Now, so, but that equals, and then you have the memory alignment, right? So we have 1 plus 4 plus 4 plus 4 equals 13. But I'm guessing it's not going to be aligned on that. So it's going to probably be something like maybe 16 bytes. 16, so it's 8-byte limits or whatever, because an 8-byte limit would be 64 bits. It could also be 32. Let's actually find out. Like, what is the memory alignment going to give us? So we could go. We can just do it down here. We can just do after person print. We can say printf size of a person struct, and then it's %lu size of struct person, right? And we'll compile, and then finishes, and then if we run it, we'll get that 24. So it's 24. 3. Did I count the bytes right? Was the char? Another thing I'm going to start doing, guys, is I'm going to start indexing these, so when they do come up in live, so people can look at them and watch them later. I am going to index them. I'm going to figure out how to do that. I'm going to write a script or something to do it. I'm going to index them so that someone can come and kind of just find the information that they want, that's useful for them. So if we go back to where we were, let's see. I also want to see what the size of a char star is. So percent %LU and N. I needed to do that too here. I didn't. Oops. I didn't do that here as well. N. Okay. And then. Oops. Size of char star. Okay. Compile. And then let's see. Oh, 8. Because it's a pointer. Duh, Keenan. That was my fault, guys. That was totally my fault. That was not your fault at all. It was totally my fault. I was just not realizing that because this is a pointer. This is the pointer, not the thing. So it's automatically, all pointers on my machine, it's a 64-bit machine, are automatically going to be 8. So, okay, so if we add that together, we do have 8, 8, 8. Okay, so let's go back and add this now. So we have 8, and then that gives us 12. Okay, 12 plus 4, 16, 20. So 24. So yeah, so since it wants to come on 8 byte alignments, that's 24. So even though we only took up 20, even though the struct is only 20 bytes. And then the string dupe for the name, so getting the name, that is automatically going to need to be a size as well. So after once the memory is the copy of the copies it to that location, based on what the stir length, I guess it is. Does it use stir? Like, how does it figure out? How does it figure out so what does it say about it? It says the stirred up function returns a pointer. The duplicate memory for the string is obtained and can be similar but copies at most n bytes. If s is longer, only n bytes are copied and a terminating null byte is added. Ah. Okay, and then string dupe A and string dupe string UPA are similar but use alloc to allocate the buffer. On success, returns a pointer to the duplicated string. It returns null if insufficient memory was available with the error number set to indicate the error. Okay, so we should be asserting after... I should be doing... the name, so it should be char name memory, name mem equals stir dupe name, and then I should assert what should I assert? If returns a pointer, it returns null if insufficient memory. Okay, assert that name mem is not equal to null. Right. So then we got our logic for and I'm an idiot. That should have went after that. There we go. Okay, recompile. Forbids mixed declaration. Where did I have mixed declaration? Char. Oh, yeah, yeah, you're right. I should be not declarating. Okay, so I did both my asserts here. So we'll just, oops. validation is here. Okay, so that's good. Recompile. Everything's good. Still works as intended. Okay, so what I didn't do though is I didn't finish. Did not finish this. Okay. So where were we at with... Oh yeah, oh here's a cool thing with Emacs. What you can actually do, see I'm over here on this, so I'm at the top of here. If I'm back over here and I'm in my line where I'm doing the main coding and everything, what I can do is I can do meta shift V and I could scroll. No? I thought you could scroll the other window. Maybe that's only in help? Or is it control shift V? No, I don't know what that did. Okay. I thought scroll other window. Scroll other window. Control meta V. Ah, okay. So control meta V. You can scroll the other window down. You can't scroll it up. So there is no scroll other window. There's only scroll other window down. There is no scroll other window up, which I've always wondered why, but in any case, there isn't. Okay. Main behavior, but did I do the right thing? Display function, okay. Prints all the attributes. Okay, I gotta finish with the display function. So let's do... Let's do HD, okay. And printf, let's say the weight or height. Height is %dn person.height. And then printf weight %dn person.weight. Okay. And then that's it. That should be recompile. Whoa, has no member height. Does it not have no member height? Oh. What is going on here? Recompile. There we go. Make sure it still works. Yep, age, name Keenan, age 44, height 72, weight 237. Alright, so quit that and go back here. Okay, program behavior. Your program should create two separate people using create function. Okay. Yeah, so that's Keenan. Oops. That's Keenan, and we'll do Control C, Control D. No. Where's duplicate? Crux duplicate. Is that Control C, D? Yes, it is. Okay. And then we'll say Annie, and obviously, oops. Obviously, she is Annie Lynch. So it does have the same age. She's like 6'5" or 5'9", so 60, 90, 60. I think 67. She's 5'7". And we're gonna put that as irrelevant for right now. We're gonna put that as we're not gonna put that there. Okay, and then if I compile again, unused variable Annie, of course it's an unused variable Annie. So we'll fix that in a minute. It should create two separate using their print their memory addresses, their initial state, modify their attributes, increase age, adjust height and or weight, print their updated state, properly destroy all allocated memory before exiting. Constraints. You must use dynamic, no stack only structs. You must duplicate string, not reuse the original pointer. Every allocation must have a corresponding free. No memory leaks. No global variables. Use standard C libraries only. Okay. Yeah. Okay, so we print person print Annie. And then let's say Keenan dot weight. He's gonna lose some weight. Let's say Keenan dot weight. Now he's 230 pounds. And then person print Keenan. Modify their average, increase age, increase height and or weight, printer updated stats. Yeah. I don't want to do that, but let's person destroy now. Destroy Keenan and person destroy Annie. Okay. Alright, so let's remove these. And they did want us to say what the memory is. Their memory addresses. Okay, printf Keenan memory address. I'm gonna do it in decimal for Keenan, and no, it's long. At Keenan. I don't need at because it is an address. Okay. And then printf Annie memory address %lu Annie. Okay, and then I need to. Do we have multiple cursors? Multiple cursors. Multi-occur. No, we don't have multiple cursors. See, that's the thing too. I want to install multiple cursors because I always make the mistake of not including the new line. Always not including the new line. It's kind of my thing. It's kind of like, it's kind of my calling card. I don't increase the new line. I need to increase the new line, but yet I don't. Okay. So let's spell memory correctly. Okay, and why is it barking about that? Okay, recompile. Ooh, format expects type long, but has type struct person. Yes. But I do want that to be the address, right? Recompile. Format. No, because that's a double address, so I didn't want that. That's my mistake. I will take it. I will take that as my mistake. But what's the format that I want? But argument 2 is type struct person. What if I do D? Oh, I know. I could just long unsigned long unsigned long star unsigned long star. Argument 2 is long unsigned int. Long unsigned int. Argument 2 is long unsigned int star. Oh, because it's not the point. I don't want the pointer to the. Okay. Because that is a pointer already, so I just want the long. Okay. Recompile. Alright. Now let's test it. Then I'm going to be going here soon. Okay. Keenan memory address is that. Annie's memory address is that. Name, Keenan Lynch, Annie. Okay. Height, weight, 230. I changed my height. We're going to say that we're not talking about Annie's weight. So, man printf. I want to do, man printf3. Man printf dot 3. I want to do hex. Convert it to unsigned octal. Double argument. The void pointer argument is printed in hexadecimal. %LX. The unsigned int is converted to unsigned octal, unsigned decimal, unsigned hex. The letters are used for conversion, are used for X conversions. Output is empty. LX. So do I want LX? Okay, so let's see. Did mine come out in hexadecimal now? Let us see. Did mine come out in hexadecimal? Hey there, how are you? Okay, let's see. Did mine come out in... Mine did come out in hexadecimal. Okay, good, because that's going to be easier to see the differences. Well, you know what? It was actually... You know what? Let me actually change it back first. Because I think it's actually easier to see it. Recompile, and then... Oh, cool. I'm glad you joined along. Let's see now if we... Okay, so... My memory address ends at 6560. I wish it would line it up. I can't remember how to do that. I think it's Mine's at 6560. Hers is at 6656. So mine starts at 6560, and I have 24 bytes. But there's probably the bytes that are needed for my name, which is, I don't know, however many that is. There's a lot of in there. And then Annie starts at 6656, and then, of course, the bytes needed for... Oh, nice. The algorithm is helping me. Yes, it is. Just hit 100 subscribers, actually. Not sure if you were one of those, but thank you for sticking around regardless. And this is what we do. We just do some, it's just a programming stream, doing programming stuff. What are you studying? So, well, thank you very much for your subscription. I really appreciate it. I really appreciate it. I want to visualize that, but I don't know if there is... Oh, okay, what kind of math? What kind of maths? Is it math where you are, or is it maths? I have UK colleagues in like Europe, and everyone calls it maths instead of math. Okay, let me go back and then change it now into the hexadecimal notation. Recompile. And then see what it... Okay, so there we see... Yeah, so... We're kind of in the same page, maybe it looks like. I would like to see what the difference, like what the padding is. I would like to see this in like in a visualizer. I don't know GDB so well to do that quite yet, but I guess we could try it out. Let's let's try it out. Diophantine equations. What course is that for? Okay. I hope your studies go good. I hope that my stream in the background is a help and not a hindrance to the studying. Okay, I'm actually going to be quitting the stream pretty soon. I need to go grocery shopping. I was actually away from streams last week. I wasn't feeling too well, so I didn't stream a whole lot. But we jumped back into it tonight, and it was a decent stream. Did a kind of reverse way of solving a problem by giving ChatGPT the solution and then having them create a problem, an exercise that if you followed the instructions of the exercise, it would come up with a similar solution. Okay. What part? I've been to Pune. And Mumbai, because you had to go through Mumbai to get to Pune. Delhi. No, Delhi, not Mumbai. I've been to Delhi. I've been through both, actually. I've been through Delhi Airport, Gargantuan, and then Pune. I know. I know. GDB main dot C, right? Oh, yeah. So it's GDB just main. Okay. List. Let's say we're going to break on B on 59. Run. Okay. Okay. So, how do we now view the memory? So help memory. This is the memory subcommands. Data, help data, okay. Help data. Binary, disassemble, dump, write contents of memory, memory tag, memory regions, search memory for a sequence of bytes. Oh. Explore type of an expression, value of a type valid and current. Explore the value. Okay. Help memory explore. Help data explore. Help explore. Okay. Explore is a valid expression or a type name. At any stage, hit the return key. Okay, so explore Annie. Okay. Interesting. Yeah, okay. Well, again, it was nice chatting with you. We are going to go ahead and end the stream for this evening. I do thank everyone for joining again. Thank you guys for getting me to 100 and now 101 subscribers on this stream. Looking forward to our Fibonacci sequence. We're going to go 100 to 300. What's the next number? To 500 to 813. We'll do Fibonacci until Fibonacci doesn't make sense anymore. So I really want to thank everybody for joining. I hope you guys all have a wonderful evening, and I will talk to you later. This is Keenan Can Do.